I'm here with Mathieu Acher, I
Yes.
suppose, from University of Rennes in France. Tell us a little bit about who you are and what you actually do, Mathieu.
Yeah, so I'm professor at INSA. It's part of University of Rennes. It's in northwest in France. And research at INRIA. It's a well-known institute, right, for computer science.
Right.
And I'm doing research in software engineering, more specifically on software variability, so how to create variants of something. And trying, for instance, to explore different alternatives to implement an algorithm or a scientific workflow. Of course, I've been very interested by generative AI nowadays because, it can change the way we create software and we think about software engineering.
Yes.
Yeah.
And how are you looking at the role of GenAI in software engineering? What is the state of practice today? What do you see going forward?
Yeah, so it's moving very fast. I studied the research by looking at auto-completion and so on. Then it moves to out of a specification in natural language of a problem, you synthesize just a function. That was part of, let's say, human-eval benchmark. And then it's moving to complete application out of 2 sentences with vibe coding, right?
Yes, exactly.
So I think software engineering is very broad. There are so many contexts. You cannot compare software engineering at Airbus with software engineering when you have end users programming a static website. So it's very different.
Yeah.
In each context, there is a potential, but there are also some challenges like reliability, because sometimes you can have very good experience and the day after, wow, it doesn't work. Why?
Right. Yeah. So, because that was one of the things that we were talking about earlier as well, I think you have a few concerns, or you have a few risks that you see on the horizon around the role of GenAI in software. Because if we look at companies like Lovable, I mean, they generate everything top to bottom. Of course, that's only one part of the software-intensive systems industry. I think we both work a bit in the embedded systems industry, where we see that the implications are not that far yet. But do you see particular risks or things that you're concerned about in addition to reliability?
I think reliability is really the key challenge. In general, I'm very enthusiastic about generative AI because it can democratize software first, opens to new people or new expertise that refuse to use software because of the lack of skills. I'm very positive, even for software professionals, but we have also to be very careful because, sometimes the code can be of bad quality. Bad quality can mean full of bugs, full of security flaws. You think that it implements what you specify, but evolves in the details, and then you discover it's not really like that, right?
Right. Yeah.
So reliability, it's really the core challenge because fundamentally, LLM and agents are stochastic by nature. They operate over probability distribution.
Yeah.
So you have to deal with this new paradigm, I would say.
Yeah.
And reliability in software engineering has been a huge topic for decades, and it won't disappear. We need to have quality assurance on our software and software engineering workflows.
Yeah. You work, I think, quite a bit with industry in France as well.
Yeah.
So what is the state of the practice in the French industry that you work with?
Yeah, so it's evolving very fast. I think at the beginning, companies were quite afraid about sensitive data. Can I use AI or not, and so on. I think the debate is still there, but they are more open, and there are also open models now they can leverage, right?
Yeah.
So my experience is that there are lots of experimentation. Not sure it's fully adopted. What I'm specifically working on right now, and that just a small portion, I would say, of the industry, on migrating legacy systems.
Right.
So that's a huge challenge because there is a huge market, right? You have, for instance, lots of old applications written in COBOL.
Yeah.
We think, okay, COBOL is... but you cannot easily replace this critical system that much. And the knowledge about COBOL is in the hand of a few person, it's not like Python,
It's not like a million people can do COBOL programming, that's for sure.
Exactly.
Yeah.
And if you migrate a legacy system, you have to prove something or to demonstrate that it still fits the original specification.
Right.
So we are working a lot on this, and because it has been an old problem, it's not resolved at all. LLMs have potential, but so migration, upgrading of software is
one of the key areas that you're looking into right now.
Yeah, right now. Although exploring variant space is also a very important topic, and also working on companies that puts a lot of effort on verification, including the use of formal methods. I think this topic will be even more important to control the generation of AI. Right.
So one of the topics, I think we've both been quite active in the product line and variant management community. So traditionally, platforms and product lines and variability management were very, very important topics.
Yeah.
How do you think this will be affected by generative AI and the approaches that we're seeing right now?
Yeah. So software product line engineering has been sometimes called generative programming. There is this famous book of Krzysztof Czarnecki, for instance. And I think it was this idea that out of a high level specification, you create software variants.
Yes.
That's a bit the same as generative AI, except that perhaps we have raised the level of abstraction, augment the productivity and the agility to. So I don't think what we have built out of generative programming, like modeling properly the variability space to control the right combination of feature and to reduce also the cost of proposing everything and to identify what are the features that matter, this will stay, I would say. But generative AI can leverage this formalism to create more easily new variants, and out of it you can learn many things like, okay, maybe that's interesting for customers, maybe this consumes too much energy. So I have written a couple of papers on this. Not solid evidence, but I would say now we have a new power for creating variants, and it should be integrated into what we have created in the past, like properly modeling and managing variability.
Yeah, so if you look at, my view has been that traditionally we've looked a lot at either you do a kind of clone and own approach and you do customization for every individual customer, or you do a configuration-based approach where every customer is basically one configuration of a existing product line.
Exactly.
The problem that I've seen is that because of DevOps, doing the clone and own and then customization becomes prohibitively expensive. And I've been pushing people towards the superset platform approach. But what I'm now starting to see is that LLMs can actually be used for very cheap and frequent regeneration of customization of platforms, which allows people to basically combine the best of both worlds, if you want. The concern that I have is, if I every 2 weeks run the customization process using an LLM, will I get the same replicable output every time? Any thoughts on this one?
Yeah, very nicely phrased. That's true that LLMs can act as a good clone and own mechanism. But let's take an extreme example. Let's take the Linux kernel. If you want a variant of a Linux kernel that you want to embed into your hardware, would you start from scratch with an agent-based LLM, or would you reuse what have been done during
the last decades?
But in between, that's an extreme case, of course. We are not.
That's a good question.
But in between, I can imagine cases in which, maybe that's good to generate the variant from scratch, because, But as you mentioned, there is this question about
repeatability and so on.
What result I would have would be a reproduction of past attempts. And also, if you regenerate from scratch, there is a risk of putting some bugs and so on. I mean, I know software is fragile, that libraries are full of bugs and so on, but still, there are some qualities here. There are some reuse that LLMs could build upon. So I don't know. It depends on the software engineering context, but I can imagine, kind of one-shot variant per customer with an LLM, but depends on the scale and the complexity of your domain.
Yeah. So we need to wrap this up because we've covered it 10 minutes. If there is, Software Center is a collaboration between 16 companies and 5 universities, and many of the people in these companies will be watching these videos.
Yeah.
If there is one piece of advice that you would want to give everyone working in the software-intensive systems industry, what would that piece of advice be now in the age of GenAI?
Okay. I think as a company, you need to experiment with generative AI, definitely. If you ignore this trend, you may miss a lot of opportunity.
Yeah.
A big challenge for me is to automate the assessment of this technology, to automate the evaluation. It's related to reliability in a sense. Because too much time experimentation are based on anecdotes like, wow, I have generated this static web page last night, it was great. Okay, but it's not really repeatable.
Yeah.
So build a way to evaluate what generative AI can bring to the table. Don't trust anecdotes, and it's hard to evaluate this kind of value. But more positively, try, because that's a very exciting time. I think it will revolutionize clearly the way we are building software.
Yeah, so I think so too. Mathieu Acher, thank you so much for taking the time. I really appreciate it.
Thank you,